Welcome to this third episode of the APL Notation as a Tool of Thought podcast. I'm Adam Bolzewski, and this here is Richard Park.
Hello.
Yes, there. This time we're together in the same room.
We're actually in person. It's
Yes,
unbelievable.
at the Dialogue Bramley headquarters office with...
Look, you might remember this from last time. Well, not if you're listening. Not that you can't. The scribblings of alternative notation ideas from the last episode are on the blackboard, chalkboard behind us.
Did we ever mention that's Iverson's blackboard?
No, I guess
that's
not.
That's the one he would teach Iverson notation on.
Yes, and here we are, bastardizing Iverson notation on the very same.
Yeah. Okay, so for today's subject, we're thinking of talking about the various functional forms.
Yes.
And when and how you should use them. And I think we should begin with a bit of an overview of what the functional forms are in the historical perspective, maybe.
Yeah, I think so.
So
it's the only way it makes sense, to be honest.
We've looked previously, and we can show a picture of it as well.
We're talking about well, I guess in the general term you could call it user-defined functions that the user can write and then assign to a name in some sense.
So Iverson developed this notation, which is very much a procedure notation, as procedural as they come, with these arrows going to places for decisions. So you have these, there's a listing. It was a linear listing of lines of code, if you want, the notation, and then along the edges, you would have comparison functions. They always compare some functions. They're predicates at least. And then if they held true, then it would branch or follow the arrow up to some other line. And then when that was linearized, then it became still this listing of lines, but it became. Let's see if we can. Do we have a example with a go-to? Okay, so it became this list of lines, and we still have the line numbers, and then you would go to with the right arrow, go to a line number, and then you could, if you go to no line numbers, it would just continue execution. If you go to a line number, or any number of line numbers, would go to the first one, and then it would jump to that line and continue. So everything was go-to based.
And that's how you did control flow.
Yeah, that was
inside a program. Yes.
Of control flow. Now that type of function have been extended in many dialects with control structures from algol, basically.
Yeah, if, else, for, while sort of loops.
Yes.
To replace the
case switch statements.
Oh yeah, select switch, case switch.
And they've been used for many other things as well. These kind of keywords that begin with colon and then some name.
Who started the colon?
I don't know. It was in the not in the very early one, because there was this called APL.
Oh right.
That they just used these keywords, which are basically what we have today, like with slight modifications.
But they're keywords in that those are reserved words in APL, whereas the way that Dialog avoided it, and I guess some other APLs.
Dialog didn't come up with this.
No, but I mean how it's implemented in
APL
Dialog
Plus
is to have the colons. So
yeah, APL X has it, and I'm not sure who was actually the first one. Maybe APL Wiki says anything about control structure.
I guess the other defining feature of these types of functions, the original form implemented in like APLs you could execute, are the function headers, which is basically mimicking the calling syntax, which is kind of a nice feature.
Yes.
The very first line of a function declaration is how you should call it.
It's like a pattern for how you call it.
Yeah.
And that also sets up the result variable name and the argument variable names, and so on. So who started spelling them with colons? A plus, I think.
Oh,
no,
really?
That's reserved words in A plus, it says. But then J added with a final dot. APL plus was the first one to start with a colon. And that's become universal. It's amazing actually with all these vendors, they all chose to go with the same thing. So all basically compatible.
Yeah.
Which is nice.
Yeah, that is nice.
And then, so
How a lot of things go.
that's the trap, and it's this very procedural thing, and it's very like it very similar to what you would see in like BASIC and so on.
Yeah.
Um,
Do this, then do that. If this is true, go over here.
but that doesn't mean you can't use them for functional programming. People really did functional programming in the sense that everything is a
It's like it's its own capsule. It takes
Yeah.
arguments
and it
and
returns
it returns
results,
results, and it does
and
not
you
do other
chain
stuff.
them together, and you can even compose them together. You can't write them inline because of the notation they use, though that could actually be fixed.
No, I guess that's the other thing about the user-defined functions have the exact same syntactic properties of the primitive functions. That's
Yes,
okay.
that's important. That's universal. All APL functions do that.
Most programming languages do that.
You know what the next one
Except
was?
for their symbol, they call them operators when they're like in languages with like more conventional syntax. The functions are the functions and then open parentheses and then your arguments. But the symbols, they call them operators.
Yeah.
Whereas in APL, we don't make that distinction. They do things, they're functions.
It's syntactically the same. Yeah, exactly the same. You know what the next functional form was in APL?
Well, so I don't know. If I had to guess, it's either going to be assigning primitives and operators together, so essentially tacit.
Okay.
Or it's going to be, but I don't think this was implemented because I've seen in an old, I don't know what year it was, but a APL course sort of binder that we've got that's like an introductory course written by Iverson, and in there it has, I think he calls them direct functions.
Yeah, direct definition.
Direct definition, and that has I don't know if it is curly braces. It might be, but it definitely has alphas, omegas, colons, and diamonds, although not in the order that they're implemented in defens. I think the logic goes the other way.
Diamonds weren't added for multi-line things. In fact, some APLs didn't even have support diamonds, just multi-line. So you couldn't do
I
that.
don't know. That's what I'm saying. I don't know how old this course is either. I know it predates defens as implemented in dialogue.
Oh, this doesn't have it. Maybe on Wikipedia it says about it. So, here's
So I know I've seen
this.
them in text.
This is what it was. So you could say a name,
That's right.
colon, and then expression, or a name and then the deciding expression would go in the middle, and then it would choose. So it's basically this function does this, but if this is true, then do this instead.
Yeah.
So it's kind of like a but if type thing.
But if, and you just
And you couldn't chain this.
go all the way down though.
No.
You can chain this?
No, I mean you couldn't have multiple propositions in a. So what we have in defense today is that you can say condition colon result if condition is true.
Yeah.
Diamond or new line, and then
if it's false, then do a different thing.
Then continue. But that's the thing. It's not do different thing. It's continue.
Yeah. Okay.
Whereas this only allows you go right or go left, and that's it. You can't chain this because the proposition is in the middle. By making it into proposition and result pair in defen, then you're able to.
So I'm seeing here name colon expression. So what's name?
The name is the name of the function when you're defining it.
Oh,
You couldn't make anonymous functions either.
Yeah. Okay, fair enough.
So, I mean, they could have, I guess, made a syntax that just enclosed it in parentheses, but they didn't. It was just you define some kind of function, and it would be defined as name colon expression, or name colon expression colon expression colon expression. 3 expressions. And then the middle expression of the 3 would decide whether you go right or go left.
And I guess so. That sounds like it sounds like they were thinking in terms of these. If you see the diagram from the APL 360 description, you've got arrows going off from the right and left.
Yeah.
So maybe they're like translating that into a notation or something.
It's a way of like stylizing a branch point, really.
Yeah.
It's not thought about as
a linearized programming language as we know them now with all experience using languages that are written on terminals and stuff.
Right. But I've built up amazing things like this. You'd have this was called a bag of functions, where you have tiny little functions because you never have more than one branch point in each function using this thing.
No.
And I don't think this was actually ever implemented anywhere. He had a model for it. So you had something. Somebody used the number 9 to like as reserved words for this, and then you have like D9 as a define function, and then
Okay.
you would use quote guard, you would prompt for text, and then you could type this and it would define it for you. So and it's
I guess by having it that way as well, you avoid having. Some people don't like long trad like one function that is a giant monolith
yeah.
that you have to navigate through. It can be windy and stuff. But by having a bag of functions, presumably a function could call another function
Oh yeah,
as
that's how
part
you
of
do
its
it. You chain
expressions.
everything up. Maybe we can find an example of it. I think
Sort of forces a modularity, although maybe too much if it's only one proposition per function.
yeah, but I mean, it becomes very clear.
Because there's no new lines in this, right?
No. No new lines, no time. So in the notation as a tool of thought, very appropriate. Paper.
Compiler from direct to canonical form.
Yes, in Appendix B.
Canonical is what we call tradfins.
Yes,
Direct is some predecessor of defens.
that's why you have it's
Canonical
called,
representation,
yes,
quad
CR.
CR.
People think it's like character representation. It's not. It's canonical representation. It's a character matrix that represents a traditional function, but today it could represent multiple things. But there's the translator, and it's a really cool thing. When I was little, I wrote this into my APL to make this work because I wanted to use this neat notation.
Right.
And yeah, see how F9 as well. And the cool thing is it builds it up. Like it's self-hosted. You start off with one tiny little thing. So notice that.
So start with 0 reshape.
So that's just
So
to silence it up. So
okay, that's just that's the result. But quad fx F9
fix has to be defined as in a traditional way.
Yeah.
As a function, and then it just takes a quote pad, so it prompts for one line of input,
And that
sends
line
it to F9.
F9 is the one that collects input.
F9 is also a trad when you have a traditional function. It's canonical function because you haven't gotten started yet. But then it does all this
okay.
stuff.
So what I'm saying, because the first line D gets F9E. So are you defining F9 on the first line?
No, this is fix.
Input?
That's one function, and then D9. You can see the header with
okay, yeah, okay.
And this is D9 then, and then there are these constants, C9 and A9, which are just alphabets and some patterns that it needs to. This is not a function, and then it just does all of that. And then I think he has an exercise for the readers, like to extend it with like multiple statements and other things. Maybe he has this multiple places, and then just redefined.
Let's see. There's an example below of using it.
Yeah, so you can see the Fibonacci sequence.
Oh yeah, pretty classic.
It's like
sum the last two in the sequence.
Concatenate them to the sequence so far. It's to take the sequence and concatenate the sum of the last two in the sequence of Fibonacci on
the
omega minus
one.
1, minus 1, and the colon, and then omega equals 1, if omega is 1, colon 1. So you can kind of see this. Okay, but this was never made into, as far as I know, a mainstream.
No, but now looking at this example, I'm seeing a del in the middle, as it were. Well, I guess not really, but sometimes it feels like that when you're recursing on a defin that you've got.
This is exactly that. I think he even added that at some point, that you could use del to represent the function itself. In which case you're almost a defin.
It's not a branch point though, but it's like something where you're going down with.
Yeah. So then it becoming this very functional style, right? The functionistas like to use these recursive definitions. That's how you do it like this. And then John Scholes, as you said, he got enamored with functional programming.
Yes.
And then he developed this more general purpose defin. You can actually look up, if you look for defins, DFNS on Wikipedia, it goes straight to the right page. He has to spell out direct function, and which is, I mean, I like it better that the proposition there is first.
Yes, yeah.
And then you can have multiple of them.
No,
defins are not perfect. They're definitely features I would want. We should put a link to John's last talk. Use a
Oh
boolean for
yes, yeah, he did have
it's like the
some.
past, present, future type thing.
What do you want in defense?
Guarded guards. So defense are these
Yeah,
case functions or
yeah,
lambdas, right? And you can have preposition colon result if it's true, and then diamond or new line, and then you just continue. You can at some point you can have more such points. But as soon as you have a condition that's true, we quit.
yeah.
And then we don't have a built-in thing in APL with these sort of short-circuiting Boolean operators like you have in other languages because they don't fit into the APL syntax. There's no way for you to say if this is true and this is true, but you don't check the second one if the first one is true.
Oh, right, yeah.
Then you could build this using lots of functions and wrapping things in functions and operators, and then you can, if you use control structures, you have and if you can use for that.
Yeah.
That's short circuiting.
Or
But
you
could
use
have,
logic to build up the condition separately.
yeah, but maybe okay, maybe if this file exists and it has more than 100 bytes in it, you can't check for whether it has more than 100 bytes if it doesn't exist.
Yeah.
So you can't, there's nothing, no modern logic will do that. You must stop early.
No, but you would code that as assigning the truth value to a name and doing an and between checking the file exists and I see what you mean.
Then you might have to duplicate code. Because
Yeah.
sorry. But so what I would like to have is guarded guards. So it's basically just more colons, kind of like the direct
Yes.
definition, but so all the leading ones would be conditions. So you say if file exists,
Yeah.
colon, and file has more than 100 bytes,
Yeah.
colon, then you do use that
But
file.
we have
Else.
empty, there's a something with empty guards. I saw it in someone talking about asserts, I think.
Oh, that's different. That's different. That's not a guarded guard. So what I'm talking about here,
Yeah, but I'm thinking syntactically,
it can
what's the
work fine.
difference if you have statement colon and then what, a new line?
So
Is that
I
what you're
wanted
talking
to
about?
that n exists
Yeah.
and omega,
if quad n exists omega, so if the file
then
exists,
and quad and info with whatever the code is for that.
yeah,
Of omega is greater than 100.
enough
Then
lines.
we read it. We read it. Quad n read omega. Oops.
Right.
Otherwise, we use the alphabet or whatever.
Yeah.
Right? Like that.
But now, if you want to do this now,
Can't really.
well, can you check? You assign the result of quad n exists, and then you'd have a guard that quits if it doesn't. Otherwise, you'd drop down to doing the quad n info.
Yeah, but you don't want to quit. You want to continue using something else, which might be multiple statements.
Okay, no, oh, no. Then you'd have not quad n exists omega colon quad a.
Yes, but what if you want multiple statements after that?
Yeah, well,
So the way you can do this is
okay.
you wrap
I see.
this, right?
Yeah.
Like this, and then put this in. So if this exists, then we run this function on this, and it says if this exists, then we do this. Else
Yeah, I see. Yeah.
quad a, right? And
So you
that,
have to have defens in defens
yeah,
in
it
order
quickly gets a
to.
bit hairy there,
Yeah.
and it doesn't read very nicely. Whereas oh yeah, no, that's not gonna. So yeah, so you could have a guard that then calls another function, which is what
The
you have to
bag.
do anyway if you want to have multiple lines
Yeah,
executed.
you'd. If I was writing this, I'd use the bag of function style, right?
Yes,
Read greater than 100 would be one function,
yes,
and then that was already defined, and then you'd call that by name rather than having it defined in line or something like that.
yeah, but you want some facility for dropping out to some other things. You need to like default this unless read something.
Yeah. It's not.
So guarded guards is something I would want, but all in all, the defense are really pleasant to use.
And it's a big because people see, let's see, they see the Game of Life video, and then all the like latest intros, even Rapelive, because new book, uses defens
Yes.
as the functional form when they teach user-defined
It's
functions.
definitely the way to go when you
People
introduce
join APL nowadays and they don't know that tradfens exist, which is
Yeah.
very funny.
Oh, and some of the hobbyist APLs don't even have it. Like
Yeah.
LGN APL, JAMA APL,
Yeah.
they don't have it at all.
And it's kind of more notationally, isn't it? If at the very least, coming up with names for the header is a pain. You can define these anonymously, which also is more notation-y than tradfens, and yeah, people prefer the functional because the primitives are functional, right? They take large. Is there anything that's not? Not really. Yeah, they take arguments and they return results. All the primitives.
Yeah,
They don't do side
they rarely
effects.
have side effects. Yeah.
Rarely.
I mean, there's slight side effects, like the question mark has a side effect of updating the
Random link
random
thing.
link
Okay,
the
yeah,
seed.
whatever. That's a technicality of the implementation more
Yeah, in
than.
principle, it could just be totally random and it wouldn't have an effect. But then there's execute, of course,
Yeah,
which runs stuff. But in principle, yeah, they're pure functions. But there's nothing that says that defense
These
have to be pure.
No,
And you can write traditional functions,
that
tradfunctions, that are pure.
yes.
Certainly, it's like you can do all the same.
No, but notationally, it's just the vibe.
Yeah,
It's just the defense have a more APL-y vibe.
and the fact that you can use them in place without giving them a name. It's not so
that's
much the
useful.
header. I think if you write a defin that's sufficiently big and complex, which we can discuss whether you should do that or not, well, sufficiently, then it might be a good idea to actually give meaningful names to the arguments.
Yes,
Even
yeah, of course.
to the
of
result.
course.
Sometimes I think I've done this occasionally, where I just say, the final expression that computes the result, and I give it a name, and the next line
It's
is
just
just
a
that
name.
name to kind of signal to the reader that this is what it is. And you can also begin a defin with saying, alpha, omega, and then you assign those to some meaningful names.
Yes, I do that as well.
Even more so if you write a defin operator, then it's a good idea to give good names to what the operators are. Unless you're writing some kind of composition where it doesn't really make sense to give them names, F and G or something. But if you're really doing something complicated,
If you get to line 15 of a defin and you're saying like alpha, 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 something, something, and you're like, sorry, what was alpha again?
exactly.
Yeah.
And sometimes it's not so obvious which argument should be what. So there's this. I don't know. It's not a principle. I'm not sure where does it even come from. This idea that when you have a dyadic function, the right argument is the main data, and the left argument is
A
kind of
modifying
parameters,
parameter,
amount, specification, that kind of thing, which isn't. It doesn't even apply to the mathematical
yeah.
functions.
I was like, because minus kind of not.
Minus is opposite.
Yeah,
That's
because
the thing.
you're subtracting from the thing on the left.
Yes, and usually when people say argument times 2.
It's structural ones, it must be, right? Because
Yes, they're for sure. All the
reshaping
APL
the
ones.
data on the right. You're taking from the array on the right, and you're returning
Yeah,
some modification of the thing what's on the right.
sure.
Uh,
Pick, index, all those.
Index, index of, but that's only because you get the same shape as the thing on the right.
What? No. No. I meant the indexing function.
Oh,
It
right.
takes the indices on the left and the data you're indexing into on the right.
Oh, yeah. Sorry.
Right?
Brain moment.
And you even have it, even in actually in.
Even though Aaron Sue immediately defines I gets, and the
And then he
argument
flips
swaps.
it because it's common the other way.
It does make yeah. It's,
Maybe the clearest one is the circle function.
You're doing.
It's the function selector on the left and the actual number on the right.
Yes,
Right?
although that's hard. It's debatable whether that's a good primitive anyway.
Okay, I like it. But the deal, you have the number. The main data is how many different ones you have on the right of question mark, and the left one is how many you want to take. The data is the cards.
So I
52
I can
cards.
understand having conventions and patterns in that way.
I'm not sure where that actually came from, but I guess if the monadic function takes the data on the right, there is no parameter. It always does the same thing.
Yes.
Then surely when you add a parameter, it goes on the left.
If the monadic and dyadic forms are related in that way.
But they always are for a user-defined function.
Yeah, that's true. Because
No,
you're not
nobody,
gonna
nobody in the right mind would write it like
you use
what
a defined
the,
function where the dyadic case is completely unrelated to the monadic
I'm gonna
case.
serve on the symbol save on the symbol table. You're gonna only use one name for this.
Yeah, no, fair enough.
But the primitives, I mean, many of them are related, right? Or they both relate to the
And there's no
symbol.
monad.
We get a little bit away from the subject here then. But in any case, it is common for APLers to do this. But of course, with something like multiplication or addition,
Oh, so
there's no one side that's the main one.
yeah,
'Cause
no, I
they're
was just gonna say I makes a lot of sense to flip them around because you're often
okay, but I
computing
means Aaron Sue's indexing function.
Yes, your compute. I means Aaron's indexing function. You usually you've got an expression that computes some indices,
Yes,
and then you're going to use those indices
in some
in
large
some array.
static data.
And so
Yeah.
you're always doing squad, swap, enclose when you do that with squad.
Yeah.
You're like array indexed by the enclosed indices I just computed,
Yeah, there are plenty of examples of it. I mean, pick also,
of where you'd rather have it the other way around.
and pick and petition and so on.
Yeah,
But I like having the there because there's this convention.
yeah.
Then I like having the commute there. They shouldn't be defined the other way because it makes it clear what's the main data. It's
If
easier to
the
remember.
main data is always the thing on the right.
Yeah,
Yeah, I suppose.
it's a little bit interesting for iota actually. Dyadic iota is reversed. Surely the main data is the lookup table, and the parameter is
But
what
that's
you're
what I'm
looking
saying, because the
for.
only reason it's like that is because it returns the same number of elements as the thing on the right. Dyadic iota. You do
Yeah,
the
but
indices of
membership it
the
returns
things
the
within
same
it.
as on the left.
Yeah, yeah.
Why does membership look up in the lookup array on the right, and index of is lookup array on the
Probably because
left?
of mathematics.
They don't. Okay, membership, yes.
Because it is the membership
No, but membership
symbol,
is regular.
and you do
It
member
does take
that.
the main data on the right. It's the iota, which is the newbie in APL.
Yeah, 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 yeah.
Why does it do that way? And also union, the way we've defined union, because they're not actually sets,
Yes,
right?
no, they're
It's also the
multi-set kind of
yeah,
things.
kind of, but they
It's
they
more
also
like
the
the
main
thing on the
data is on the
left.
left. It preserves the elements from the left and adds additional elements from the right if there are any to add.
Yeah.
But that surely the principal argument is on the left and the intersection um, without or except for the tilde.
So you're like, I like this convention,
But it's actually
but
broken
here's
kind
all
of
that. It's
now.
like I before E except after C. There's more.
There's more exceptions than the.
Than things that follow the
But
rule.
still, I mean, the monadic dyadic thing. So okay, so all of these functions are functions where the monadic and dyadic form are not actually very connected. Those are the cases when it's reversed.
Yeah, that's true. So what have we been?
But so what I wanted actually to say with this was that when you have a defin and they're called alpha and omega, which is all very nice for left and right side of the Greek alphabet,
Yeah,
but 20 lines down, if
yeah,
it's
yeah,
not a type of function where you take a parameter and some main data,
yeah.
can it be a bit like how do I call this? And having the first line of the function say that the left argument is this, the right argument is that,
Mm,
is actually quite nice. And
yes.
that's the cases where you
Well,
can,
in general, if you've got something substantial and you're trying to make it maintainable, the first part of your function is like comments about what it does, information about what the arguments are. So my my friend who hates not untyped languages, right? He's like
wait
in
for
computer
not
science.
untype.
Well, untyped
Oh,
languages without types
without
or
typing.
without
So the
typing.
dynamic language.
Dynamic languages, that's the word.
Hmm.
He hates them because he's like, well, what's the first thing, what's the fundamental thing you can know about a function? So
Yeah.
what arguments does it take and what does it return?
Hmm.
And obviously computer scientists are always thinking about that in terms of types, whereas the domain expert, the computer user is like thinking semantically, what's the meaning of the
Yeah, so I don't think I need the
arguments and
types, but
results?
I want to know what do they represent.
These days, I like to have a little bit of, I'll be like, this is a nested vector and it represents this thing. And I'll notate that by saying, like, alpha colon vec of or nested vec of vec. There needs to be a nicer way to notate that. I think John Scholes did have some kind of pseudo type notation
Yeah.
he was using sometimes, and then colon colon, and then the thing that it represents. And sometimes I'll write it like that. I'm playing with ideas because I don't know. It'd be nice to have a convention.
But it's not so simple because often and that can even be a goal in itself there,
Oh, to not have
to write code that's not necessarily agnostic and normalizing, but able to handle
different.
anything.
Yeah, so then whatever this type of header type declaration notation would have to have ability to be ambiguous in that way to say that like it's just an array of numbers or whatever, you know.
So let's say you have the case conversion function that
Yeah.
we just recently added called C.
It takes an array.
It takes anything whatsoever,
Yes.
right? And changes the case on any characters it finds, ignoring anything else than characters
Yeah.
in any structure
Yeah.
whatsoever. That's like the ultimate, right? But that's a scalar function. You can't
And
do
it's also what you're saying about these, like you were saying when you're defining compositional operators, you don't know what the thing's going to you don't have the semantic information.
But you might know the type. You might expect that both operands are functions, not
Yeah,
arrays,
exactly.
for example.
So
you
it
can
needs
say
to
that.
it needs to be flexible to do that.
There you want different kind of type of. Then you want a usage type where okay, I expect my right operand to be a monetic function.
Yeah.
Right? For example, the add operator, its right operand must be a monetic function. It can be ambivalent, but it's only being called monetically. But you cannot give it something that's strictly dead. It just won't work.
Mm.
So, but it's not. I don't type annotation is going to be really tough for that kind of thing because it's not. People think of it as like for functions. It's it's the calling syntax. How many arguments do they take?
And what type of those arguments
What type of
sometimes?
those? But that's not what we're talking about here.
No, no, we're talking about largely for the human reader to
Yeah.
understand what is the purpose of this function and how do I use it.
So for the add operator, for example, it must be a function
Or-
that you can call monetic, the right operand,
Yes.
monetic function, a function you can call monetically that returns a Boolean result that has the same
shape as
shape as the argument
Yes.
that it's given.
And how do you? So I don't know. Yeah.
But it's not a classical type thing.
No,
It's
no.
it's
I think
depending on.
I think it's more useful than just saying like
Yeah.
it's a array of ints.
Yeah,
Like
that seems so
whatever.
low level.
Yeah.
You get it. Okay, so these are the defens, and they can do more things. You have error guards and things like that. And then there are tacit functions, which you've got plenty of videos about and things.
Yeah. So when did you be able to assign plus plus left arrow
Plus
cross plus gets plus or plus some
St.
gets some
Andrews
gets
cross or something.
St Andrews or George one of
George,
the
what George and
no
Andrew?
George
One of
might
them.
be the
Yeah, I think so.
is the Scottish one. No, Andrew's Scottish, so that's the cross one. George
Yeah.
is English, so that's the plus one.
Okay, so that actually started
That's
really
time.
early on. That's
Just
time.
like
St. Andrew's choice is time.
All right.
And then the plus symbol is St. George's cross.
Yeah, I think that's how I remembered it. St Andrews is the Scottish one. St George is the English. What killed the dragon?
Okay. Nobody calls them that. Plus sign and times sign.
There's no one calls it that. But there are some old bits of literature about APL that refer to them like this.
So that at least the idea of that was really early on. Iverson had a paper on where he wrote about the benefits of a model where you could do that kind of assignment.
Right.
And Dialog implemented this from the beginning, I think. So like I don't know, 82 or whatever it was it started.
Right.
And then and then they added the compose operator.
Mm.
And then you could compose things together, but you didn't have trains until Dialog 14.
Yes. Well, until J.
Well, Jay had it for many years.
That's
but
what I mean. Like you didn't in the history. We're talking like history of APL.
Yes.
And it's the one thing that I found surprising. I think is you sort of get involved in an APL like dialogue or whatever, and you sort of learn these features. And you kind of learn that some of them weren't always around or whatever. But then over time, you're sort of picking up these things. Oh, these ideas have all been around for a very long time, almost since like near the beginning of APL as a notation. All these ideas have been like
Right.
thrown around. People have talked about them, made models of them and stuff. And it's only been like, I don't know what the reason is, just time, effort, inertia of
Yeah.
people not, being super strongly advocating for them. Defense took John Scholes just like doing it. It always takes someone just doing it
Oh, he
before they
had a
actually
long
become.
phase of thinking about it first, I think,
Yeah, of
and
course, yeah.
implementing it behind the covers kind of thing, and then suddenly it was just there
Yeah,
in all its glory. So, but tacit functions, and then they get extended. The more compositional operators you have, the more you can do with those.
yes,
And finally trains
yes.
as well, which is really a composition of
Yeah, it's a
three
syntactical
functions,
composition, yeah.
of three functions or two functions.
3 and beyond.
No, because it's never more than that.
No, it's
Really.
it's a recursive 2 or 3.
So now we've got three functional forms that you can use in today's APL.
Yeah.
And,
Tradfens, the canonical definition,
yeah.
with the header and very procedural, and
Well, the option of being procedural.
the option of being
I mean, you
procedural.
can do a functional thing. And
Can
then
you go to in a defen?
No.
No, good. With go to and control structures of that ilk, then defens.
where you don't have control structures available, not because they couldn't be syntactically speaking, but it's just disabled.
Yeah.
Actually, there's a trick, you can make them work if you wrap them in quotes and execute them.
Don't do that.
No.
Don't do it. Don't do that. And yeah, tacit definition, which is
Well, tacit program. We'll do a whole
Tacit-
episode on that.
tacit programming, which that comes from the opposite of the way I remember it anyway. Tacit is the opposite of explicit, where explicit you explicitly refer to arguments using some name, be that ones you've given or alpha and omega in the case
Yeah.
of defens.
That's the definition, isn't it?
Whereas tacit is implied arguments. There are rules for how the arguments should be passed to the functions that you're tacitly defining, but you don't mention the arguments explicitly.
You do not identify the arguments.
And defens were controversial, right? They were for some users, people were like, "Oh, I don't like defens. Don't see myself using defens." Now people can't get enough of them. There was a question. I think we talked about this on whoever was on it, a previous Arraycast episode, or no, maybe I don't think I was on that one. Henry Rich, the J dude, and there was some conversation there about like, are you into tacit or whatever? And it was this whole like, it's good for up to some people they like it up to a certain length, but if it's beyond that, I don't really get it. But there are some people who come in and it really gels with them, and they will write some like long, using a loaded term, monstrosities. They're just like,
the official term is pornography, I think.
Oh yeah.
So
pornographic.
Well, there was a while when Aaron Sue was doing everything as tacit as he could, other than operators, which you can't in APL. And then, I suppose Roger Huey as well. I mean, he's the one that got the trains into APL.
Yes.
And then Roger reverted on that. Well, not really. I asked him about it, and it's not that he was against them, but he says it requires much more discipline to write good tacit code than it does to write, or at least
yeah. I say that's like sounds about true, but hello, welcome. So Pete, it's about it. Well,
time.
Yeah, we got time. Unless we edit this out, there's people in the office and there's meetings we're going to have in about 15 minutes. So people have been coming in and wondering what's going on in the room that we've occupied. That's about it.
We're at the headquarters. We mentioned that it's live from the headquarters.
We should have we didn't put in the calendar
No.
We could have invited everyone on. Come on down. We'll introduce the whole
paper in the door
team
saying
dialogue.
recording in progress.
Doesn't matter. What we're talking about, yeah, discipline to write tacit, and then that sort of, you said that because I remember this coming up in the like optimized operands for some of our operators, specifically, I guess stencil and key are the main examples, but there are other
Rank.
ones. Rank as well. So like having because the way Dialog implements some of these optimizations, they're called idioms in the documentation, but they're
No,
not.
that's a different thing.
They're set phrases.
That's a different
No,
thing.
but they are. These are also set spellings. They're not okay. These are not idioms, but they have.
Set patterns or compositions. It could be that the operator recognizes a certain operand and then goes to special code.
Yeah, but that operand has to be a specific spelling, right? Like,
Not necessarily. The
Right.
idioms are always token by token the same. You can put in spaces, but that's it. That's the only thing you can vary. How many
you can
spaces
put
you
in
have.
spaces. Okay.
Yeah. Or possibly, token. So like there's a rounding idiom, which is
Yeah.
the floor 0.5 plus, and you can leave out the 0 and 0.5, or you could leave it like 0.5000, because it would be normalized to the same token,
Yeah. Okay.
and you could put spaces
By
and
the
so on.
parser.
But the special operands for the operators are they're a little bit different because you could have, say, for stencil, very often you have a
Oh yeah.
vector thing. So
Plus slash comma a times omega, where a is
exactly,
an
and
array.
A can be any array that's conforming to that, and it still does it. So that's not an idiom. Idioms are kind of
Yeah.
dumb in the sense that it's just a phrase. You see this, you replace it with some optimized code.
Oh, so that's like closer to funkishness.
Yeah, it's a pattern recognition in
Yeah.
in
Okay.
the interpreter, right?
Right.
Um,
But when those are put in for some of these operators, the defen version, for example, I think omega with stencil or enclose omega with stencil possibly.
yeah,
Both of those are optimized
yes,
in the interpreter. But right tack or enclose the top right tack are not.
they weren't.
They weren't.
I think we fixed it
Okay.
eventually, but for a long time it wasn't.
And
Which annoyed me to no end that the longer one was optimized and the shorter one is not.
But I remember hearing that an argument might have been, and this is pure hearsay, I don't have a source, but did Roger Hui said he preferred the defense style?
Yes.
He said he preferred having
Yeah,
the
so then he kept writing things in defense style when it could obviously be written tacitly, and I was wondering what's up with that. I asked him. It's not that he's against the tacit thing, but you don't just send off an email with some tacit code. You can just send off some code, an email
defen.
with a defin. But if
Yeah.
you wanted to go tacit, you have to go and sit and think about it.
If it's long enough to warrant that, like the benefit I find of Tacit, at least in my current state as a APL programmer,
Mhm.
is the phrases that are idiomatic and that you use over and over and they become recognizable, the things that are like you don't even have to think to know what it's doing because
So the idiomatic phrases
yeah,
or
which
idiomatic
you know,
functions.
I guess the evolution of that is like the APL idiom lists, the most famous one being the Fin APL idiom list.
Yeah.
But those were expressed in the most recent form as defens, I think. Those lists, aren't they?
I've translated them to defense.
Some of the old lists have got like expressions where it's a name or like
Yeah,
inline assignments
that's
and
that's
working
how
on
they
that.
all are. It's only when I put things into Apple Card that I made them
Oh,
into
okay.
defense, and after that. But that's often it's because they're not suitable for tacit anyway, because they're using too many monadic
Mono functions
functions or
and
and
go,
reductions that you can't really do a tops with properly.
yeah, right. So that
So,
makes sense.
but yeah, so, and obviously for you it would be the cut, right?
Yeah, cut's
Is
the best
the
one.
different from
In,
partition right tag.
yeah,
Where, yeah, and there are others, and the average one is of course very
average one's
famous,
famous, yeah.
and then
But beyond that, it all requires
so we have
repetition.
these three functional forms. Possibly you could say that the tacit comes in two categories: the trains and one function compositions. But it's a bit.
Yeah, I prefer not to make
There's a
those
big
things
difference as to whether
sometimes.
or not you need to parenthesize them when you apply them,
Yeah,
if they're not
if you're
named.
writing them in line and in order and applying them that way, then yes, one needs parenthesizing, the other doesn't,
No, actually, that's not even true.
because it depends on the binding. No?
Yeah, yes. If you have, say, minus jot one, that's a decrement
Yeah,
function
right.
that you need to
So,
separate and
you know,
well, not
there's
parenthesize, separate.
there's a fair argument, and it's annoying because sometimes you got really short things where you're like, you don't want to emphasize the use of operator because it just makes it a little bit longer and uglier. But then sometimes isolating visually, for me at least, isolating visually that this part is a function, all the stuff inside the parens is this function that's going to apply as functions do, you know.
Yeah, I like it sometimes when you have a dyadic operator that's deriving a dyadic function. Then I sometimes think it's kind of nice to have the
But then
parentheses to indicate what the
sometimes,
function
because of
is.
the way the operator is defined, you have to parenthesize one side of it anyway. So now you've got this parenthesize thing that's computing something you're using with the operator, and then you're like, oh, I don't want to parenthesize on top of that. So I only use the right text sometimes.
Do you ever parenthesize the operator and its right operand? So
Uh,
here's an example. So let's say we do like quad A, right? And then we want to add a lowercase to it. So concatenate that. And we want to do it 3 times.
X concatenate.
Right?
Yes.
So you do this.
Yes.
But the only reason here to parenthesize, or we could use a right tag,
is to avoid stranding.
is to avoid stranding. So now you can parenthesize this instead. So you parenthesize just the power operator with the 3.
No, wait. No. Don't do that. So the difference is comma. So yeah, essentially, so power being a dyadic operator has the left operand, which is a concatenate in this case, comma, and then the right operand, which is number of times 3. And yes, I would parenthesize the whole thing together, the derived function.
But this is valid, right? So here we have
yes,
x,
valid syntax. But
x,
it's,
comma, open paren, power operator
God,
3,
no.
close paren. No, but so this forces you, when you said that the power operator, you have the left operand, comma, concatenate, and the right operand 3, doing it 3 times. Then your order is kind of wrong. It's a power operator. It has a right operand, which is 3, and the left operand, which is concatenate. Now it has the left operand, which is concatenate, right operand, which is 3.
I see what you mean.
Okay, and so this forces you to think
power
operator 3 is a derived new monadic operator called thrice.
Yes.
And so this says x concatenated thrice to the alphabet.
Yeah.
It looks odd. Because you're so used to that monadic operator needs to have a left operand, and here it doesn't kind of have a left operand. Right?
Yes.
And it's valid enough.
And it's hard when it's small, right? Like I say, sometimes I won't. In general now, my feeling is to favor parenthesizing whole derived inline functions, as is demonstrated on here. But when something's so small, and like I say, when there's an extra parenthesized expression on the left of it and things like this, then I might use a right tag. But I can see what you're saying about the semantically concatenate thrice argument for this version. And obviously I'm used to the other one, so that's why it's slightly crawling on my skin a little bit. But also, just reading something longer that contains this, I feel.
I mean, I find that parentheses take a toll on my brain. I need to build up a stack that or
if you have lots of nested ones, yes.
Yeah, but the shorter inner parenthesis is, so if you just say like tally omega in an expression, I can just read it as a unit. So this keeps by only parenthesizing the operator and its operand, then and one operand, right operand, then you can minimize the amount. And here, for another example, minus open paren at 1 close paren, in some numbers, and so that negation on the first one, which you can read that first, right? Negate first.
Yeah. But ultimately, you are
maybe the most obvious example of doing this, and I've never, I think, seen this done, is with the rank operator, where you parenthesize the right operand because that makes a new operator. So for like rank 1
on major cells, rank negative 1,
or on vectors, on matrices,
on vectors and matrices.
Yeah, so it's rank 0, 1. That's a new thing. And sometimes row-wise, you can call it, right?
Row-wise.
And then, and so it kind of makes sense to parenthesize the right operator and its right operand.
Yeah, I'll have to play with this because the other thing about it is ultimately you are still on top of this deriving a function. The function applies to the
Well, then
arguments.
you use this derived operator to derive another function.
Yeah, which you've not parenthesized in a sense
No, because it doesn't need to.
because it doesn't need to now that you've done this.
Well, you don't parenthesize every primitive that
That's
you
what I'm
use.
saying. I'm gonna have to play with the style a little bit and see how I feel more because
But
I'm not actually. It's not as my initial reaction there, but now I'm like, maybe
maybe there's
maybe
something
I
to
should
this.
try that.
So for trains, right? So a simple one would be so let's say like here, 10 open paren plus comma minus close paren 2. So it gives us 12 and 8.
Yeah,
And here it's a functional composition. The comma in plus comma minus is acting as a dyadic operator,
yeah,
binding two operands.
yeah.
And so it makes sense then to use the same kind of form. So if you had plus over minus, it's adding the negations.
Right, and then part of me is like, okay, so I've got an inline derived function.
Mm-hmm.
No matter how it's derived, be it trains or compositions, or it's just an operator.
Just
Now I
parenthesize.
parenthesize that whole function. I know that like that function is the unit that I'm acting on the arguments with,
And whether the middle thing is a function, an operator, or a function doesn't really matter.
and then I can use that with trains. I can use yeah.
Because
Whether the middle thing is a
Iverson
function operator, yeah.
had an earlier idea, which was that
There should
at
be.
least some functions should have operator equivalents, where they would take two operands and then apply those the same way
Oh, that was as an idea for
before they
trains.
came up with trains, right?
Yeah.
As I like to put it, like they were struggling to figure out how to represent f plus g in
Yes.
APL, and it took long time until they figured out they could represent it as f plus g.
Yeah,
But
it's true. When you get deep in the weeds,
you don't see it.
yeah, I don't see it.
And so, but yeah, this idea we have like overbarred scalar functions to do.
Mm,
Anyway, I like before we have to end because
yeah,
the time is almost up.
yeah.
Then what we actually wanted to discuss was when should you use these different function
Yeah, it's possible we've peppered in hints throughout the conversation of like when we prefer to use things. The examples are obviously different.
Yeah.
Maybe it's clear or maybe it's not that like my opinion at least is tradfans define a procedure almost like a script, a sequence, or like an overarching structure to a program. Defens, you can use them for that, and vice versa. You can use both of these forms for either of these sorts of things technically, but defens I prefer to use for like an explicitly functional, if not purely functional, transformation or something like that most of the time. These are not hard and fast rules. And then tacit is like for me short, obviously functional. Well, pure
Has to be.
kind of has to be for the reasons we said earlier about primitives being. Unless you can write named functions in here, but it's kind of like I find that a bit obfuscating when people write. Apart from in the Aaron Sue or Whitney style, which is to have short one-letter names for functions that do kind of there he's like building up a notation for doing that domain, and then sometimes he'll define it'll. I don't know if he does this, but this seems like an excusable reason. Is like I'm writing a function that's derived from three other functions I've defined, and those have all got one-letter names, and so it's a bit notationally that way. But I don't know if I.
Actually, there's another reason to use tacit functions. I can show you.
Yeah.
That is when you need to pass values around, but you can't afford to use names for it. And so I will actually somewhat frequently use system functions, or almost exclusively system functions with like right text and left text,
Right.
to do something and pass something around. So I'll show you an example.
You
Actually,
don't have a
something,
loose name that you have to get rid of later because you weren't really using it.
yeah, and you don't run the risk of clashing with anything or overwriting anything. And so I have an example that is something I sent to a customer actually, which was a type of lazy loading where I was saying that you wanted to copy in Conga. What Conga is the communication library.
Yeah.
Right? And then, but you don't want to keep it there all the time. So you just want to have I wrote it as a function, a niletic function.
This is
which
the Conga workspace.
Conga workspace has two namespaces in it. When you copy it in, you get two namespaces.
Okay,
Conga
so
and
copy in a name.
DRC. So what I wanted to have is the ability to pretend like that Conga is there and call it without changing anything in the way you call things.
Mhm.
But it actually isn't there until you need it. So it's like a load on demand. You can implement this as a niletic function,
Right.
which is, I think, one of the valid reasons to use a niletic function, because it has the semantics of an array, like a namespace, but it's actually runs some code. So the way I did it was, see if I can type it all up here. Is so we want to return a reference to the Conga namespace. But the Conga namespace is not there. We have a function called Conga. So I want to copy in Conga. I need to erase the current Conga because that's this function.
Yeah. Okay.
Even it will remain on the stack as long as it's running, but it will be gone because I'm going to overwrite it. So I erase that, and then I want to copy in the Conga workspace.
Yeah.
So I copy Conga, but it's the same argument here. And I'm not actually interested in any results from any of these. So do that, and then I want to return the value of Conga, which is just the evaluation of the string Conga. So then I can do execute here, like that.
Is it a known and like usable fact that the right tine of a fork is executed first? It seems from what you're writing here that is the case.
It certainly has to.
It has to be for the definition you've written here to work.
Yeah, it
But I
does
never thought of them that
consistently.
way because I never used them with side effect having functions.
You
To
provide any
say that,
guarantees?
like, to me it's almost like the left and right tines. It could be either way, like or asynchronous.
I mean, it's super easy to check, right? Just have them have side effects.
Yes, this is that's true in terms of like factually and implementation wise. I was thinking in principle.
So we have a train that
Is that what you would want? Would you want that
an
fact to
L,
be true?
comma, print an R. And Martin thinks that I'm crazy for doing this kind of thing.
People are trickling in for the meetings we're delaying now.
We're giving it a dummy argument here, and right is executed.
And it makes sense, in the APL right to left execution. Like I'm just saying it's something I hadn't thought
you don't
about
actually
before.
need this quad EX here because quad CY will just stump over whatever is there.
Yeah.
So this is enough. But this is, I mean, I think it's pretty neat to do it like this. I don't have to worry about any temporary names to move things around. I just replace it like this, and you can do this with files as well. So if you're doing a raw read from a file, so you're using tie numbers, so you do a quad n tie, and then these days you always use this automatic allocation of a tie number. So it returns the tie number it allocated.
Yeah.
Then you want to read all the bytes from that, which is just some more parameters, and then you want to untie the file.
Yeah.
And so you can just do the tie, and then the result from that you feed to a train, which is the read and the untie, and then what is sticking as a paper is saying, do not use trains with functions that have side effects.
That was, we're
That's his opinion.
Well, Adam's arguing one specific case, which is like a quick come and gone sort of thing.
I don't see why you shouldn't use trains with things that have side effects. If the syntax comes out nicely like that, then you should invite Morten on as a guest to explain his position.
So the example here is very much like a thing that is come and gone, like as soon in the same very briefly, it's very short, fleet, exactly. It's not a like
ephemeral thing. It's just the tie number. We never need it. It's just pass it through.
So I think that's a fairly large caveat to add to.
Oh yeah, I mean you don't want to do a giant GUI application.
Exactly.
There you want to go for the trappings, for sure. And I've seen a lot of people, I think it's abusing defens for doing this kind of non-functional thing. They're great for these mathematical things, even if they have some guards in them where you need some switch points. And their scoping rules mean that they're good for certain things. But as soon as you start doing like object-oriented things mixed together with defense, and you have to fight the defense that want to terminate as soon as they compute some kind of result. They're not made for this kind of
You got a lot of underscore gets everywhere.
Yeah.
Because
Until you start using like the Dewey library, which uses underscore for like its entry point into various graphical elements in
Really?
HTML, and then when you use underscore gets, which that has happened to me as a sync, then all of a sudden it auto localizes in the defin, and that's not actually what you want.
Oh no.
And then you can't access the library anymore. So this is abuse, right? This is not what you should be doing. And even those that do like the defin gets an object as argument, and then it modifies the object, and then sends it back again as a result.
Oh yeah.
But that doesn't really work well, because as soon as you make changes to it, it's globally changed. And so returning it is it's kind of fake functional programming that you're turning it on, because then
it's just a nicety of the code, right, to make the code feel a bit more deliberate or whatever.
Yeah, but it's like
it's not.
So it looks functional, but it's not functional, because it's having spreading its effect right and left and globally, and it can affect other things that run in parallel. Really shouldn't do that. At that point, I would say thread fins are the way to go, and they're not. I don't think they're really clunky. Some people say like, oh, that's so old-fashioned. Like, the control structures are a little bit verbose compared to using braces.
Naming arguments is hard.
So you use X and Y. You really have to.
A and W.
Yeah, I see that sometimes. I think I've done that myself.
Anyway, let's wrap this up.
Yeah.
We're gonna do the rest of the,
so now we know.
day.
Yeah.
Now we know all about functions.
Yeah, we better get started with the work and actually using them in those ways. Thank you for tuning in.
All right.